great. Thank you all for coming out. I guess I'm just going to wander see what happens. Just a quick sense of who I'm talking to. How many of you write CSS at work? Or not at work? Wow, a lot of you. Great. Backend developers? Yeah, some? Okay, cool. Great. Yeah, that gets me a sense. Fine. We're going to talk about CSS. I'm Miriam Suzanne. I founded Oddbird with my brothers. We're a small consulting agency. We're all remote. We're doing all sorts of things for clients. That's just context of where I'm coming from. Yeah, this is me founding the company with my brothers. Definitely doing our first card sort there for a client. Really getting into the agile. I also built Suzy. You shouldn't use it. Great. So we're going to start with 1989 is when Tim Berners-Lee invents HTML. The first website and the first browser come in 1990. And then the second browser pretty much right away. But right from the beginning, there's this concept that HTML has to fail totally gracefully, and it has to work everywhere. And everywhere means text only. And so he says right from the beginning on that first website, it says, that means we're never going to be able to do anything like colors or fonts. There you go. And it's true. Like, we can't, in a way, on the web, because the web does have to work everywhere. And that does include text only and smartwatches or whatever. And so it really is a problem. There's this problem. How are we going to design for an infinite, unknown canvas that changes every day? I don't know. Like, that's absurd. It's an absurd thing to try to do. What we do in CSS is totally absurd. So he right away built the second browser. This is the second one, because the first one required a graphic user interface, and he was like, I want to prove that this works everywhere. I'm going to build a line mode browser. It works in the command line. You can still go play with it. You can go play with this first website on this second browser. And it's all command line. And that's still something we have to think about when we're building with CSS. And CSS is designed for it specifically. And didn't come that much later, depending how you do your numbers. The spec for CSS, the first proposal spec, came in '96, and then it wasn't implemented in a browser until 2000. So it's several years after Tim Berners-Lee says we can't do it. A few people proposed a way that maybe we could do it. But all of that, oh yeah. and then we were done. All of that is trying to find a solution that allows us to actually be able to do this, to design for all of these devices. And this is a fraction of them. And we're not just talking about different screen sizes, we're talking about different screen capabilities, different interfaces, different ways of interacting with them. These things, and also a braille reader and headphones. The web is intentionally, from the beginning, built to work on all of these things. And yeah, fonts and colors aren't going to work there. He's still right. But what we have is a language that falls apart very intentionally in a graceful way. And what we're doing with CSS is building these like houses of cards that are supposed to fall apart gracefully. And that's everything of CSS. That's the whole mental model of CSS, is how is it going to fail in a beautiful way down to nothing, down to no styles. So we get this declarative syntax, which puts all of the control in the hands of the browser, in the hands of the device. It gets to make all the decisions about what it can do and what it can't do. And then everything falls apart from there. And the browser needs all that information so that it can make decisions. So that's why we get the declarative syntax, but it's not a static result. CSS isn't static just because I say background red. Background red might work some places and not other places. It means a different red on different devices. All sorts of variations. And we're gonna make some even wilder variations, but yeah, it's this absurd design for an unknown canvas. That's sort of, like, okay, CSS intro, done. Let's play with some of the toys. The first one that we got here that I'm going to be playing with, I'm going to be playing with a lot of CSS that came before this, but Calc came in 2011. We get the first implementation of it in Firefox 4, and we can start writing these functions. We can start combining something that we couldn't combine ourselves. There's no way for me to know how you combine 16 pixels with 20%, but the browser does know that because the browser has all that information. And this is again sort of that, like, well, the browser can figure it out and give us something. So we can start combining relative and fixed widths there. And then in 2014, we get CSS variables. How many of you are using CSS variables? Less than are using CSS. The question that I always get is, what's the browser support? It's fantastic if you're ignoring IE. But we have to remember that that's the way the browser works, that's the way CSS works. A CSS feature is never supported everywhere. That's the whole point. CSS features always are simultaneously supported and not supported, and what we're thinking about is how are they going to fall apart. But we're going to play with variables a lot. Oh, right, we actually did have a variable before. It was sort of an automated variable, this current color variable. They look like this. They're also called custom properties. They're sort of that dash, and then a name, and then a value. And that's basically just an empty browser prefix. So we had -webkit something, and now we have just our own. Take out the browser prefix, it's my own prefix, I name it. And then we can call it using the var function, which takes the name of the custom property that we've created, and then after 1 comma, there's a fallback value. And that can be confusing if you're doing a fallback that has commas in it, but everything after the first comma is the fallback. So if you put like a font family, font stack in the fallback, it will work all as one fallback. That's roughly how they work. We're gonna play with them. Let's get that presentation up. Do I need to go bigger there on the text?
A little bit.
All right. So I've got a couple nested divs here. The outer one has an ID of outer, the inner has an ID of inner. Then I've got paragraphs and some buttons inside of them. I've defined this variable called color, and on the root selector, I've given it a color of red. And on the HTML selector, I gave it a color of green. And I did that. Let's actually get rid of, oops. This is the fun of live coding. You're welcome. So right away, if I set something on the root in HTML, that's going to be the HTML element. I've set it to a color of red, and I've called it as the color of my paragraphs. And you can see there, that's how variables work, just the fundamental. The reason that I might not use root is because that doesn't do anything. I've seen lots of people suggesting that you set your variables on the root, but root is actually just a higher specificity version of targeting HTML. So if you want a global variable, I recommend setting on an HTML instead of root, so that we don't run into that sort of specificity conflict ever. There's a couple weird things about variables that are the reason I have this nesting here. So let's just think about it without variables for a bit. If I've got this inner P, that inner paragraph is going to be green, and then I set the outer paragraph to be red, what's going to happen? They both turn red. Because what we've done, they're both targeting both paragraphs, and they're both the same specificity, so later takes precedence. And that's basically the problem that people have solved with BEM, and we can do that here. I think I created a class for it. BEM is sort of a way of saying, like, okay, let's not target the same paragraph, right? Let's avoid that duplicate targeting. And that's also basically what automated scoped styles from, say, view or, let's see, we want inner there. Scoped styles from JavaScript generally are doing the same thing. They're just sort of automating, creating that, like, oh, this paragraph is a direct descendant of this, so we're going to give it a data attribute. And so all of these are ways of working around this problem where when we're dealing with a cascade, there's no way to say, actually use whatever selector is most proximate to this paragraph, right? So when we're targeting that paragraph, it's going to ignore proximity, that inner is closer than outer, and instead it's going to go based on cascade logic. The fun thing about variables is that they can get us around that. So instead of doing this, we can say that the color of a paragraph is our variable color, and then inner has a color of green, of greed. Awesome. And no matter what order they're in here, right, we had outer second. Outer has a color of red. And here, because we're relying on this variable inheriting, and inheritance does use proximity instead of specificity or code order. So we can get around this thing that we've been working around with scoped components or with BEM syntax. Suddenly that's gone because we can do this thing where we can set a value one place and inherit it somewhere else. And that's sort of a clever thing because we couldn't do that with just direct. It targets everything in there, not just the paragraph, right? So it's a little too broadly scoped when we do that. But this ability to say, okay, capture this, store it, and then we'll pick it back up later. Does that make sense? Good, okay. So that's what variables are cool for. It also means we can use that. Did I have anything else here started already? No. We can also use that for things that are going to change, like say our buttons. So we can say buttons have a color, or let's give them a background. That's often how buttons work, right? A background of green. But if we've got like variations on this, the variations could conflict potentially. So instead, we say we'll give it a variable of button color with a fallback of green. And then, how did I name my buttons, you know? Nobody knows. Okay, I just have a danger one. Danger can change that. And actually, this is an interesting thing right here. Unlike JavaScript or most other languages, I can define a variable or call a variable before I've ever defined it. I've not defined button color anywhere, but I can already start using it, and that's super helpful. I would call it like a free variable or something. It's something that I can then pass in an argument later. It's sort of like setting up a property on a component that I can then pass in an argument to that property, and I can provide that fallback there. So then, in a context where I want to pass something in, I can and say dangerous buttons are red. And not only that, I can also do it based on context if I want to. So I can say inner buttons are red. So this not only gets me around some of that like specificity versus proximity issues, it also gets me around adding specificity every time I want to target something in a new place. Rather than adding any specificity, I can just use one selector to say, in this context, I want to change how this thing works. And this is all, to me, this is a little bit different from what we're used to with Sass variables or with JavaScript variables or any other language. We're really dealing with, there's a reason they call them custom properties. And it's because they work like properties in this way. And we can sort of manipulate and cascade with them in fascinating ways that are different from any other type of variable. Let's go into this one. Oops, don't do that. Let's do that. So the other thing we can start to do, so here I have a variable called stripes, and that variable is global and I can inherit it anywhere. And so then on the body, I can apply the stripes, right? So I can capture more than just one value, I can capture this whole gradient. But let's say that I want to add an argument to this, I can do that as well. And I'll put toRight as the fallback, and say angle. So now we have this angle value, and I'm going to try first, this is what makes sense to me. We'll give it an angle of 45 degrees instead. Nothing happened. The reason for that is we inherit the calculated value, not the entire calculation. So this variable is resolved back at the HTML level, and then we inherit the entire resolved chunk. So if we want stripes available everywhere and able to adapt anywhere, we have to give it that star or something else that scopes it so that it is targeting the body tag directly, and then it will recalculate once it gets there. Am I making sense still? I know I'm going like right in. So that's the reason that we might want to use star sometimes rather than going directly to the HTML and having it scoped. I don't have, let's see. The other thing that I can do, because I can ignore these variables or use them, I can start using them inline in HTML. So let's do, that's not how HTML works. Angle of 20 degrees on main. And then let's have, basically, let's make this more of a mix-in. So anytime we can right away, hold on. Let's get rid of that for a second and just show. So I've got this applied to star, applied to everything, and I apply it to a background image, and I have no angle defined, nothing happens. And this is one of the really great use cases for open variables, variables that haven't been defined anywhere. I'm actually surprised that that's working because I would expect it to fall back to toRight here. Oh, it's just, there's nothing for it to, we need that 100 VH height so that there's a page. So if we want that variable actually open, we can leave that variable open in such a way that we've now created a mix-in, where until we give it an angle, nothing appears. So then we can say, I'm going to pass it an angle, and we're going to make sure that main also has that height, or it's dead. And then it appears because we've defined an angle. The other thing that we can do is we can say, I want to fall back to another variable that is my angle override. And then, even though I've got this high specificity inline style on the I can still override it in my CSS. Oh, I actually want that to be first, don't I? So angle is going to be the fallback, angle override is going to be the default. And then if I pass it an angle override of 90 degrees, I'm going to get that. So it makes for totally safe inline styles because we can just ignore them. We can just override them with another variable. It doesn't do anything unless we ask it to. So suddenly my JavaScript developers can start sending me all sorts of inline styles and I don't care because I'll use the ones that I want and I'll ignore the ones I don't want. Thank you. So those are some of my favorite things about variables. We have so much more to get into. I'm going to keep moving. If you want to dig into it, I wrote an article on Smashing Magazine. I tweeted out the link to this deck, so you can go find that. I rebuilt all of Suzy just using CSS variables, just to prove that you can. Still don't use it, but it does work, and it's fairly interesting because it's actually kind of a cleaner syntax in some ways. I mean, the code is absurd, but you can start stringing together these custom calc functions in various ways, and then access them in various ways, and you can get the entirety of Suzy just out of that. Another thing that you can do with variables, you can start playing with them to manipulate Hsl values. So we can set like an H variable, S variable, and an L variable, and then we can pass those into Hsl. And then that means that we have those raw values that we can do calc functions on. So we can say the complement color is our hue minus or plus 180. Hue is radial, so it doesn't matter what direction we go if we're going 180. And it doesn't matter how close we are to the edge, it will just keep going. So we can also figure out triads by subtracting or adding various numbers. And then we can get our complement color to our base color. Lightness and saturation are clamped. If you go above 100% or below 0, they'll just stop. It will still work, but they'll clamp at 100 or at 0. And we can use that to do a sort of a toggle from 100 to 0, just by making sure that we go over in either direction. So we can get a contrast color roughly. This is not going to consistently pass WCAG, but it gets us close. And we have this. The only JavaScript here is taking the values that I put in and turning them into variables. But the complement is determined automatically from the hue, and then this threshold compared to the lightness toggles when we switch from black to white. And it's just that algorithm to do it. And you can get much more in depth with that. I have now on my site, I love using this ability to have undefined variables and string them together in fallbacks. So I have on my site this OS mode. I'm trying to get the mode. Do I want light or dark? And light is 1 and dark is -1. And then I can set what I'm getting from the operating system here based on prefers color scheme. I change the OS mode. And then in the HTML, I can mark something as being either light or dark, and that changes the HTML mode. And then I get my given mode by stringing together, did the user pass one in? Let's use that. If not, let's use what I got in the HTML. If not, let's use what the operating system gave me. And I think there's one more. If not, 1. We'll go light as the default. So I'm getting all of these defaults, stringing them all together, whichever one I'm given, then I apply to actual mode. The mode is the given mode or 1. So I've sort of got duplicate fallbacks in there, but that's fine. So we can get quite complex with that, stringing together various sources of data and ranking them. How do I want to rank the user's opinion versus the HTML opinion? Now I'm going to totally switch over to grids for a second, because what we're really here to play with is putting the two of them together. And if we don't have both of them, how are we going to put them together? So grid, I love the new web, where we get, it was seriously in the same weekend. I left work one weekend, and grid wasn't supported anywhere. And I got back on Monday, and grid was supported in 3 browsers. Like, that's cool. And it happens because the CSS working group now, all the browsers implement behind a flag. And so they're all working on their implementations at the same time. And once they've all agreed, they all just flip that switch. So it's a really cool new world we live in, where we can do this layout that used to be, I mean, this isn't exactly the equal height columns of the Holy Grail layout, but similar. We've got that nav going equal height. The whole thing is sort of a sticky footer. It stretches to fit. Let's look at actually, have any of you played with the grid inspector in Firefox? Some? It's pretty cool. So here's my main grid. I just clicked that and it turned it on. And let's make that bigger too. Oh, you can see I had a breakpoint there. I've labeled these grid, the grid by default gets these line numbers. So 1, 2, 3 doesn't seem to be labeled there, I'm not sure why. There's still some bugs in this. And then 1, 2, seems like there should be a 3 on that row as well. And then they're also negative indexed, so we can also go -1, -2. So we can align to those, which is what we have here. Let's get rid of that. So what we have here, we say display grid. We set up the grid template columns. So we can set rows and columns separately. We can also set both of them. And we're just using this repeat syntax that gives us 12 repeating columns at 1 fraction each. That's a new function that we have for doing that. There's almost no reason to do this anymore. Those 12 column grids came out of limitations from the past. Why would we use 12 equal columns? That's silly, but here we have it. And then we can lay something out on that by saying the grid columns should start at line 1 and end at line 4, and the grid rows start at line 2 and span 2. So we have various ways of assigning where things go in space. They go in both directions, however we want, and they can actually go off of our template, and the browser will create new lines for us off template. So we can say line 4 even if we've only created 3 lines. Then we can start to do this shit, and this is what I love. So we can say grid template areas, and we can draw a little ASCII art picture of it. We can't do any L shapes. These have to be just rectangles still at this point. But I've got header along the top, and then down the side I've got nav, overlapping main and footer. So I've created those areas and I've named them, and then all I have to do to lay things out on them is say which area should each thing go in, and they pop into place. And then I have this single source of truth where I've like drawn my layout from above, and I can start messing with it. And I never have to change what areas things are assigned to. I just change where those areas are in the layout. So I can do a mobile first, and actually this is what's gonna happen by default anyway, so I probably don't need it. If I just set the other to be above a certain width, move to this template, I can start changing my layouts based on all sorts of things, all in one place. I'm only making changes one place, and the whole layout moves to fit. And that's how I got this, and that's how it does that change from our ASCII art of them stacked to then at a breakpoint changing the ASCII art, and that's all I changed. And there we have the layout we wanted. With grid, you can also overlap things. There's no problem with any of that. There's all sorts of, grid is so powerful, we're all gonna lose our jobs. So in 2018, Jen Simmons started talking about this idea of intrinsic web design, what we can do now with all of this stuff. And she's talking about moving beyond responsive. So she talks about, like, we had, at one point we were doing paste up on paper, and that was even a big step from the previous. And then we moved to tables on the web, and we're messing with those, and then we start doing like the sliding doors technique and whatever. We've got all these techniques, but then we get to responsive design at a certain point, and we're combining fluid. Basically, we're making everything fluid. Force everything to be fluid, and then use media queries to change it at different sizes. That's responsive. And she's saying we're beyond that. Responsive isn't enough now. We've got true fluid, which I'll talk about in a bit, and we can combine it with fixed because we have these smarter layout tools that can put these things together. We have stages of squishiness, which is the fact that different types of fluid values in grid move at different times, which is a fascinating thing to play with. And we'll get to some of those in the fluid. They're truly two-dimensional. We have columns and rows. We've got nested contexts. We don't have to do grid everywhere. We don't have to do flexbox everywhere. We don't have to abandon floats entirely. We can use all of these things, and we can put them in nested contexts and say some components are grid-like and some components are flex-like. Flexbox was designed initially to go with grid. It was never meant to do layouts the way that we've been doing. Flexbox is meant to take items that are different sizes and unknown and have them take up space together. That's it. So if you've got unknown sized items and they need to share the space, Flexbox is perfect for it. If we have elements that need to fit out, that's great. And so we can switch back and forth between those. We can expand and contract content. We now have min content, max content, all sorts of other values that give us this ability to say how big and how small things need to get. We have min-max, which I'll show you. And then media queries as needed, which we don't always need them because grid does some of that for us, which I'm not sure if I have examples of that in here. We'll see how much time there is. So thinking about fixed and fluid, pigs, m's, and percents, and this might be shocking, are fixed. Percentages we've always thought of as fluid, but as far as the browser is concerned, that's a pixel value. It's just a pixel value that has to be calculated on the fly, and that's it. With fraction units, which are similar to Flexbox, grow and shrink, which don't have any units, fraction units are similar. It's a slightly different algorithm, but a similar like sharing of space. Those are truly fluid in that it really depends on what else is around. Not just the size of the window, but like sharing space with siblings. So now we have this truly fluid fractional way of dealing with space that gets us away even from percentages. And then we have this min-max fluid until fixed. Min-max is a function that takes two values, a minimum and a maximum. Shocking. And it will be fluid somewhere in between those. And this is where she talks about the stages of squishiness. Min-max moves first. And then fraction moves after min-max is complete. So you can actually have these, like something that grows first, and then another thing grows once the one hits its max, then the fractions start working. So you get these stages of squishiness, which is pretty great to play with. And then we have auto, which just returns us to standard flow. Standard flow is what we've always taken for granted. It's the air we breathe, but we need to start naming it because it does things. It's inline and block and how they flow together. And we can use it still. If you're ever wondering about these various relative units, percents are relative to parent, width specifically. VW or VH is relative to the viewport. So those are slightly, sometimes those might be the same thing, but sometimes they're different. Sort of like M's and Rems might be the same thing, might be different. And then fraction is relative to available space, which can be negative. We can have negative available space, and then fractions will become negative values. But it's once everything else is calculated, the space that is left over or that is needed, how do we share that leftover space? So that's the truly fluid. Wow, I haven't even gotten to the big demo. All right, if this is a little trick that might get you, if you ever just say one fraction, what you're actually saying is min-max auto one fraction. So you can set something to be one fraction and suddenly it gets huge, and that's because its auto size is big, like you have a big image in there. So if you ever need one fraction to also get smaller, you have to say min-max 0 one fraction or any number that's smaller. The minimum can be whatever you want, but it's by default auto. So this is where I started to really play with these things. We had a client who needed this day planner. And I looked at that and I said, okay, that's a grid, and I've got a couple variables. I've got the start of the day and the end of the day. How long is the day? And that will give me the number of columns that I need. And then I have, for each event, where does the event start? Where does the event end? And then the first thing I did was I built a chart because somebody else had done it, and I was like, great, I'm going to put that in variables, and here it is. And both of the things can change. So I have one value that's the scale, that's setting how many columns are on the grid, and then I have individual values that are the value of that item, and it's laying out on the grid using calc, taking that raw data, using calc, and generating a layout on the fly, also generating the colors on the fly, using that ability to adjust Hsl. I had to play around with it. None of this is like stuff that just worked the first time. It's like put in a random number, see if it works, go into the dev tools, hit up and down arrows, find, oh, 87 looks good, it's probably 90. So that's where dynamic CSS came from. And then to start playing with it, I had to learn JavaScript, except that JavaScript can't be learned. So I was introduced to JavaScript. I don't know why that's true. So here's the big demo. I'm basically trying to put together a day planner, and it's going to have temperatures. Those are in a table right now, and then it's going to have events. And I'm going to have to move through this pretty quickly. But I used Vue for it because Vue allowed me to very quickly set up this, like, I could add a style tag. Oh, this is very small, huh? I could add a style tag that's dynamically generated from data. That's all I needed from JavaScript, and some buttons that change the data. And then otherwise, I'm laying out a table here. And we're just gonna set it up quick if I can live code without hitting all the wrong buttons. So I start by giving the whole thing a minimum height of 100 viewport height, so that it's taking up the space. I already have this gutter variable, just gives me a little bit of spacing. And I'm gonna create a grid layout. This is for the page overall. We've got sort of like some header information and some editing buttons, and then we've got temps and then events. It's not a very complicated layout. I've set how each row is sized, and then down here, how each column is sized. Once we have subgrid, we can start to get more creative with some of this stuff. Grids can be based on like the automatic sizing of the things inside of them, and that sort of bubbles up. But right now, without subgrid, it doesn't bubble up enough, so it's hard to do with full pages. So it's a limitation right now. That's why I'm not using this min-max auto one fraction, which is what I would really want. Right now, I'm just letting things go to fractions. I can also do row gaps and column gaps and grid gaps, and those are coming to Flexbox 2. It's just going to be called gap. Right now, grid gap is supported better, and the specific ones. And it's gutters in our layouts with no extra math. This is why you don't need Suzy anymore. Suzy was only necessary because gutters are hard. And now, gutters aren't hard. And I'm out of a job. All right, this is where things get really interesting. So I passed in the day start and the day end, and then I'm just giving myself an hours per day variable that is the day end minus the day start, right? And that tells me how many hours do I have. Then I've decided I want to be able to break an hour down into multiple pieces, so I've given myself a columns per hour. How many columns do I want on the grid for every hour? I've decided to go with 4 in this case, but I can change it here, and it will update everywhere. Then I figure out the columns per day by taking the number of hours times the columns I want per hour. And in every case like this, basically I could make this as much simpler or more complex as I want, right? I could just set the number of columns I want as one single value. I wouldn't need to do all these steps. It's the question always with abstraction is how abstract? And there's no right answer, it just depends on what you're doing. So then I get a column size, and it's that min-max 0, 1 fraction, so it can grow and shrink. And then I'm building a day template out of that information. I'm using that repeat function, and I'm passing in the columns per day and the column size. And I've just defined this as a global variable. Well, inside of the day planner, it's available, and it gives me that same grid that I can reuse. Again, if I had subgrids, I could maybe set this on an overall thing and then nest down in, but I don't. So that's not going to do much on our page because we haven't really applied it. But I'm going to do this where I create a linear gradient that also uses the hours per day, 100% divided by the hours per day to create the size of the gradient so that it gives me a visual of the day. Does that make sense? Maybe. All right. Let's move into the temps because they're the most fun and see if we can get through them. Because laying out the events is basically the same as the bar charts. So I'm going to say for the temps, they're going to display grid. This grid is just sort of setting up the overall layout. We're not getting to, it's the data row. Each row of the grid is what's going to have our temperature or our day template applied to it. So each row of the grid is going to lay out on the day. So let's get that. That didn't work because, I'm hoping it's this. Right, because I need each one to span a full hour, not just one column. So I've got to say grid column end for each cell is going to be the length of an hour. So save that, and now everything lays out on the grid we've created. I'm going to start playing with writing mode. Writing mode has been available, I think it's since like IE 5. So if you're scared of using writing mode, don't be. The only thing that's new in writing mode is the sideways value, but in this case, vertical is going to work fine for me. It's just giving me a little bit more space there. And then let's start actually creating these temperature graphs. So for the range of the graph, I'm just going to take my high temp and my low temp, which I'm passing in from JavaScript. What's the highest temperature? What's the lowest? And that's going to give me a range of values. So I'm going to say, okay, my scale only needs to show that range. It's going to have a grid that repeats that number of times with a min-max of 1 pixel, 1 fraction. And my time's up. Am I okay to go a little longer? Great. So, yeah, before content, background, what am I doing here? All right. Oh, before we show that, yeah, all that we've done here is we've created grids. We can show them. They are going to be gnarly because there is a lot involved in that grid. It doesn't even see, I guess it's going to 28. Oh, when you're doing the whole day grid, there's something like a limit of, for the client, we did a minute per column. Every column was a minute. You can get about 16 and a half hours that way. So you have to go to 2 minutes per column if you want a whole day. Pro tip. There's a limit to the number of columns in a CSS grid. So I'm going to, on each cell, I'm going to do this generated content that's going to show the graph. The generated content takes the high temperature plus 1 because grids are 1 indexed and temperatures aren't, minus the actual temperature that we have. So I'm taking the top of the range minus our actual temperature, and then that's the start line, and then the end line is -1, which is the end of our defined grid. So each generated content is going to start at its temperature and span, there we go, to the bottom. Great. Now, to get those temperature values to jump to the bottom, I'm just going to set them to be on the -1 line, and they're going to start there, and they're going to go over our grid. But that's allowed. We're allowed to go over the grid, and they should all just jump to the bottom. That grid got really small suddenly. It might be because I've got this sort of negative issue, and we'll fix that. That comes from the fact that I don't have any extra space. I went exactly the range of my temperatures, and that gives me no space to work with at the bottom. So I'm going to do this calculation instead, where I say, let's take the high temp, and then we'll go to a minimum temp if it's provided. If not, we'll use the low temp or 32. But then I can set a min temp that's padded, and I just have this padding variable, and I can set it to whatever I want, and it will add that much padding at the bottom of my, well, that got us positive. I'm not sure why we're still so squished. But, you know, that's live coding, and we're just going to keep going. So for each temp value, I'm going to figure out a color. And this is where I really had to spend some time in the dev tools hitting up arrows and down arrows until I got anywhere close. And I can show you some of why that is. Oh no, I have it built in here. So I start with the fraction, so I know where I am in the range. And this is that if you divide the target divided by the context, you get the multiplier. This is how you get a percentage width. And then I've got my new range is 180. So I find out where I am in my old range, which could be 32 to 80 degrees or whatever. I find out where I am in that. And then I take my new range, and I get the temperature hue by taking that fraction times the new range. And that will say, okay, go to the same place within 180 degrees. And that's going to create my hue. So now I'm getting different hue for each one. But that's not beautiful. I mean, we don't really want our... oh, it is right. I thought I needed this hue direction offset first. Well, it's not quite right. So I mean, like, we don't really want greens as our hottest temperature. That's not exactly what we're looking for. And purple is our coldest. So then I figured out another calculation that just flips and offsets the wheel. So we've got the color wheel, and I just needed to flip it and turn it to get the colors that I wanted. So hue direction -1, that flips the wheel, and then hue offset 90 turns the wheel, and now I'm where I want to be on my color wheel. And there we go. Colds are blue, hots are red or orange, and we're cooking with or without fire. All right, let's add some animations to this because we can. We're going to have each of these generated contents grow, scale from 0 to 1 on the y-axis, and we're going to allow passing in a new speed, a new delay, and a new easing. By default, we'll ease in out. And then that's going to resolve both directions. So there it goes. Let's see, can I just force one of these to be bigger or something? Oh, I'm gonna lose it as soon as I refresh anyway. All right, so I don't actually want the transform to start in the center and grow out. I want it to start at the bottom and grow up. So that's what that will do. But then I also want, I want to be able to set a delay that changes across the row, right? So they kind of do the swoop thing, because that would be fun. And initially I tried to do that with counter or nth child. Nth child I would have to like auto-generate, like with SAS or something, I would have to generate all of the different nth childs. There's no way to like automate, add something per nth child. So that didn't work. And counter, there's not quite a way to get the counter to, oh, you can't use counter inside of a variable. You can only use counter inside of content. So instead, I have each one pass in its own index as an inline variable. And then I assign that to a delay by multiplying it by 50 milliseconds. So the first one's going to be delayed 50 milliseconds. Well, indexes, there's 0 index, so the first one will be 0, and then 50 milliseconds, and then 100. And they'll keep going, just because this delay is based on the index that gets passed in. So we can see that, unfortunately very small. I know how to get it bigger. But maybe not. All right. The other thing that I did here was I can build selectors based on the style tag. So I can say, when you see this variable being set in an element, when it's being set in line, select that and provide all these defaults. So every time ease is getting set, I'm going to provide all these easings that you can get to, that I don't want to try to remember. I just want them available. So now, out cubic and out quart, I've got all these easings that I can call, and in my JavaScript somewhere, I can say what easing to use. I can say, use the easing of var out back, and pass that in, and now that easing will get applied, and they'll all go out and back. All right, that's enough for that. I will wrap things up here. I mean, so I was giving this talk, and I saw somebody demo an art piece that they had done in processing language, and I was like, that's just grids and variables. So I built it here with view again, and you can change the sizes and you can change the number of invaders. I haven't figured out a way to shoot them yet, so if somebody wants to fork this and figure out how to kill the invaders, that's great. I also just started playing around with different types of charts that I could create, setting in values and then using them to set grids. This one is actually using clip paths instead of grids. So the values are applied to a clip path, and then when you change the values, the clip path updates. Then I saw somebody doing sprite animations at another conference, and I was like, oh, okay, that's just data. I can pass in a sprite sheet and say, what row am I in? Where do I start? What's the size of the box? How many are there? And I can just run through them. So I stole her sprite sheets. And all of that's being generated using the same way, passing in the 3 values for each one. And then to make sure that I wasn't lying, I made it so that I could change it to Metroid. Please? Yes. There we go. So pass in a new sprite sheet, some new data, and it all still works. And this is what I mean by dynamic CSS. Instead of writing the styles that I want, I'm writing algorithms to determine the styles that I want. And then they're being automatically generated from the data. If you want more on variables, Leah Veru is amazing and has some great talks that just go into depth on variables. Rachel Andrew has a great site that will get you going on grid, how to get started easily. She even provides fallbacks for common layouts. So you can just copy and paste some of her code and have working sites. Jen Simmons' Layout Land is amazing. It goes into depth with all of this. And check out her labs, it's where I go if I need inspiration. It's where she just experiments. Thank you. CSS is truly awesome. Have a good night.